So why is n to the 0 equal to 1? Well, first let's look at 3 to the 4. 3 to the 4 means 3 times 3 times 3 times 3, which is equal to 81. 3 to the 3 is equal to 3 times 3 times 3, which is equal to 27. 3 squared is equal to 3 times 3, which is equal to 9. 3 to the 1 is just equal to 3. And what is 3 to the 0 equal to? So to get from 81 to 27, we divide it by 3. That means to get from 3 to the 4 down to 3 to the 3, we divide it by 3. Then to get from 27 down to 9, we divide by 3. That means to get from 3 to the 3 down to 3 to the 2, we divide it by 3. To get from 9 to 3, we divide by 3. That means to get from here to here, we divide by 3. And the pattern continues. To get from 3 to the 1 down to 3 to the 0, we divide by 3. And 3 divided by 3 is 1. So 3 to the 0 is equal to 1. Well, this is going to be true for any number, so we can plug in n if we want. And the same pattern holds every time we divide by n, which means that we're going to end up with n to the 0 equals 1. And we can put a box around this. Let me show you another way to think of it. If we have the number 60, it's equal to 6 times 10. We can think of this 6 as a 2 times 3, and we can think of this 10 as a 2 times 5. It's still equal to 60. Then we can rearrange these to put them in order. So we have 60 equals 2 times 2 times 3 times 5. Now, how many 2's do we have? We have two 2's, so I'm going to rewrite these as 2 squared. Then we have 1 3, so I'm going to write that as 3 to the 1. And we have 1 5, so I'm going to write that as 5 to the 1. All of this is still just equal to 60 because I haven't changed anything. So now how many 7's do I have? I have 0 7's. How many 11's do I have up here? I have 0 11's. So 2 to the 2 is 4, 3 to the 1 is 3, 5 to the 1 is 5. This is still equal to 60. Now what is 7 to the 0? What has to be 1? It's got to be 1 because it's still got to be equal to 60. Same thing for 11 to the 0. It's also equal to 1 because we need this whole equation to equal 60. So now how many n's are up here? Well, there are 0 n's. This also has to be equal to 1 because we can't change this. And because of this, we can conclude that n to the 0 is equal to 1. And we can put a box around this. I've got one more way to look at this. If we have something like n to the 5 over n squared, we can rewrite that as 5n's over 2n's. So we can cancel out n's just like this. And so we're left with 3n's over the number 1. And we can rewrite that as n cubed. The shortcut for this would be rewriting this as n to the 5 minus 2. That's a faster way to get to n to the 3. Well, this is true in the general case. If you have an n to the a over n to the b, that's just equal to n to the a minus b in the exponent. Now what happens if both of these are a? If we have an n to the a over n to the a, that's going to be n to the a minus a, which is n to the 0. Looking at this is the same thing divided by the same thing. That's equal to 1. Since all of these are equal to each other, we can just say n equals 1 and then bring that piece down and put a box around that. So here are 3 different ways to think of why n to the 0 is equal to 1. How exciting.